Welcome back. In this video, we're going to talk more about unit circle trigonometry. So really what we're going to be doing in this video is drawing more reference triangles, finding more values of sine, cosine, tangent, secant, cosecant, and cotangent, and solving more problems that involve the intersection of a circle and the terminal ray of an angle in standard position. And the text above had a description for, our good firm definition of a reference triangle in our pre-calculus class, but I figured I'd just keep going and show you me making them. So we're going to sketch two 30, 60, 90s and a 45, 45, 90. That'll be good practice for us. So if we're going to sketch three reference triangles, we need three XY axes. And the reason we're going to draw two 30, 60, 90s is we're going to draw one with a reference angle of 30 degrees. So I'd say that'd be about there. And then we make our reference triangle always by going back to the x-axis. So that's a right angle. And on our reference triangles, the hypotenuse is 1, the short leg, or at least for 30, 60, 90, the short leg is a half and the long leg is root 3 over 2. What else was I going to say about this? Okay, yeah, what makes it a reference triangle is the fact that, one vertex is at the origin, another vertex is on the x-axis, and the hypotenuse is 1. So that means that it corresponds to an angle on the unit circle. And the other reference triangle I'm going to sketch is with a 60-degree reference angle, so I'm going to draw that way up there. I'm going to draw the other leg back to the x-axis, because always the x-axis. Indicate that that's a right triangle. I probably should have gone in there. I'm going to label the reference angle. But this one will be the same way. The hypotenuse will be 1, the short leg will be a half, and the long leg will be root 3 divided by 2. Then for the last one, I'm going to draw 45-degree reference angles. Go out that way. Fill out the triangle. And for a 45, 45, 90, the hypotenuse is 1, and the legs are both root 2 over 2. All right, so those are going to be the three that we're going to continue to work off of today, the same ones that we worked off of last time. And I know we talked about this last time, but I think it's going to be good for us to once again review the steps we're going to take when we want to evaluate a trig function with a radian input. Just to remind you, first we're going to find the angle location on the circle. Okay, then we're going to draw a reference triangle. Always drawing a reference triangle is the most important step. And then the last step is easiest of all. We're going to do SOHCAHTOA. So, for example, if we were asked to find the value of the cosine of pi over 6, we would find pi over 6 on a unit circle. So there's x and y. Pi over 6 is a 30-degree reference angle. Okay, that's nice, but I don't have time to install software right now. Okay, and we draw ourselves our reference triangle. Okay, pi over 6 is equivalent to 30 degrees, or like this. Okay, we are labeling our reference triangle. Hypotenuse always 1. It's 30, 60, 90, so the short leg is a half, and the long leg is root 3 over 2. Okay, then we're going to, let's see, off the screen. Do SOHCAHTOA. Cosine of pi over 6 is going to be adjacent over hypotenuse, and so that's going to equal square root of 3 divided by 2. Okay, so and that's pretty much how we're going to operate, even when we move outside of the first quadrant. So let's keep going. Let's move outside of that first quadrant and into the second quadrant. So we're going to sketch a reference triangle that corresponds to theta equals 3 pi over 4 radians. Okay, first things first, to draw the circle. Okay, we're just going to assume this is a unit circle unless we need it to be something else, and then we can work with that as needed. First, we got to find 3 pi over 4 radians. That's almost all the way to pi. I'm going to think of that as 4 pi over 4 minus 1 pi over 4. So the initial ray of my angle is going to start over here. And then the terminal ray is going to be almost all the way to pi. It's just short by pi over 4, which is 45 degrees. And that means the terminal ray is going to go right there. Perfect. Okay, so step 1, find theta on the circle. Okay, step 2, we're going to draw the reference triangle. So that's going to involve going back to the x-axis. And just emphasize it with a little bit of that. label the sides like we normally do, and then we're going to find the value of the sine of 3 pi over 4 using this reference triangle, because it's going to work out fine for us to use that reference angle to find sine, cosine, and tangent, just provided that we're a little bit careful. Now, for sine of 3 pi over 4, it's not going to matter. It's going to be opposite over hypotenuse, root 2 over 2 divided by 1. So I'm just going to write that down. But for cosine of 3 pi over 4, okay, I will point out that we are over here in the second quadrant where x is negative and y is positive. See, I even went ahead and labeled that far left edge of the circle. That's going to be where x is negative 1. Okay. Moreover, the coordinates of that blue point I've labeled where the terminal ray of 3 pi over 4 intersects the unit circle, that's going to be negative root 2 over 2 and positive root 2 over 2. Without getting too deep into it, and we'll talk about this next time, really, the real definition of sine and cosine. Without getting too deep into it today, what I'll say is in order for us to use this reference triangle and not having to think about the obtuse triangle that's kind of defined by the two blue legs, we're going to have to just be considerate of what quadrant we're in and allow for the possibility that the side length of a triangle could be negative. So we'll say that the cosine of 3 pi over 4 adjacent over hypotenuse is going to be negative square root of 2 over 2. Now, let's do the same thing for 2 pi over 3. All right, so I'm going to get an XY plane, sketch you the initial ray, the terminal ray. Okay, 2 pi over 3 is pi minus 1 pi over 3, so back from pi by 60 degrees. That might be a little exaggerated, but I think it'll make for a good reference triangle. Okay, we've got our theta equals 2 pi over 3 labeled. The reference triangle is gone or is drawn, and then I'm going to label it, right? Hypotenuse is 1, short leg is a half, long leg is root 3 over 2. What I like to do is, just with the 30, 60, 90s, the 45, 45, 90, just label the sides, and then after you've labeled them, take a step back, look at the drawing, think to yourself, which quadrant am I in? Okay, I'm over here to the left of the y-axis. I'm over here where x should be negative, so I'm going to make that side length negative 1/2. But I'm going up from the x-axis, okay, so y should be positive. Okay, I could point out, the coordinates of this point here are going to be negative 1/2 and positive root 3 over 2, if you were interested in that. But we're not as interested in the coordinates of this point as maybe some other people are. Okay, the cosine of 2 pi over 3, I'm going to use this reference angle. Say cosine is adjacent over hypotenuse, and so that'll be negative 1/2. And then the value of tangent of 2 pi over 3, that's going to be opposite over adjacent. So root 3 over 2 divided by negative 1/2. I'm going to keep the top the same, change the division to multiplication, flip the bottom. Okay, do some canceling and say that's negative square root of 3. Okay, and that'll do for us. All right, so I could ask you when theta is between pi over 2 and pi, and I'll point out that means when you're in the second quadrant, which of the trigonometric functions are going to be positive and which of them are going to be negative? Okay. We saw that the side length that ended up being negative was the horizontal side length when we drew these reference triangles in the second quadrant. So for example, like a reference triangle in the second quadrant was over here. It didn't even matter what the angle was. It was over here where this one's negative and that one was positive, right? The vertical side length was positive. And for our reference triangles, the hypotenuse was always 1. So what I'll say is that positive is going to be opposite over hypotenuse, okay, because they were both positive, so that's going to be sine. And the ones that were negative were, we saw cosine of theta was negative, and we also saw tangent of theta was negative. And what I'll point out is that, if sine of theta is positive and cosecant of theta is 1 over sine theta, 1 over a positive number is still going to be positive. So I'm going to say sine and cosecant are both positive. And in the same way, I'm going to say cosine and secant are both negative, and tangent and cotangent are also both negative. All right, now I'm going to speed it up a little bit. We're going to move into the third quadrant. We're going to sketch a reference triangle that corresponds to 7 pi over 6 radians. First step is figure out where that's going to be on the circle. I'm going to say, okay, that's pretty close to 1 pi. It's a little bigger than pi. I'm going to say that's 6 pi over 6 plus pi over 6. And then I'm going to draw myself a reference triangle. And then once I get the reference triangle drawn, then I'm going to say to myself, okay, what quadrant am I in? Which of these things are going to be negative? And in the third quadrant, both x and y are negative, so I'm going to label both of these as negative side lengths. So if I'm asked about, secant of 7 pi over 6, I'm going to use this reference angle. And I'm going to say secant, well, it's related to cosine, so I'll start with cosine of 7 pi over 6. That's going to be adjacent over hypotenuse, negative root 3 divided by 2. As a result, I can say that secant 7 pi over 6 is going to equal negative 2 over the square root of 3, which we know is negative 2 square root of 3 over 3. And if I'm trying to find cotangent, okay, I'm going to say, all right, tangent would be opposite over adjacent, so cotangent will be adjacent over opposite. That's also an option you've got. Just kind of piece through it without doing it, without writing out tangent first. For me, I think I like that because that will not require me to rationalize the denominator. So negative root 3 over 2 divided by negative 1/2, that's going to equal positive square root of 3. So since both of the red legs of the triangle were negative, I'm going to see that tangent and cotangent will be positive in the third quadrant. Now, while I'm on the topic of positive and negative, I figured I might as well just go ahead and answer this question. When theta is between pi and 3 pi over 2, which means the third quadrant, which of the trigonometric functions will be positive and which will be negative? Okay, so if I drew you a kind of sample reference triangle, doesn't matter where it is, and just label the sides as positive, negative, okay, both were negative, we saw. So on the negative side, we're going to definitely have sine and cosine both. So sine theta and cosine theta. And as a result, we can say cosecant theta and secant theta will also be negative. Like I just said a moment ago, tangent of theta and cotangent of theta will both be positive in the third quadrant. Right. The other third quadrant example I got for you is one like it's talking about terminal ray of an angle in standard position is intersecting a circle of radius 12 at point P. I need to draw a diagram. All right, I'm going to copy in the same diagram, but I'm not going to necessarily commit to it being 1. Okay, I'm going to say maybe this one's going to have radius 12. Okay, but we're going to do everything the exact same way otherwise. We're going to first find the angle. 5 pi over 4 is a little bit bigger than pi. It's going to be pi plus pi over 4. So that's 45 degrees beyond pi. Then it says it's going to intersect at point P. So maybe I'll change up the color scheme a little bit from what I've been doing before because P is eventually what I'm hoping to find the coordinates of. Okay, the next step is going to be to draw a reference triangle. Okay, it's going to be a 45, 45, 90. So the hypotenuse is 1 and the legs each have length root 2 over 2. Okay, and I'm going to think about it. They're both going to be negative because I'm over here in the third quadrant. All right, but I know in reality this 1 is not accurate. It's a circle of radius 12. So what I'm going to do is I'm going to scale this circle up by a factor of 12. So I'm going to multiply all of the side lengths by 12, and then I'll have, a reference triangle that's accurate to a circle of radius 12. When I actually multiply those numbers, I can see, all right, the coordinates of point P, I'm going to go 6 root 2 to the left. So that would be negative 6 square root of 2, and 6 root 2 units down, so that's negative 6 square root of 2. And those are going to be the coordinates of point P. Now let's move into the fourth quadrant. So we're going to start by sketching a reference triangle that corresponds to theta equals 5 pi over 3 radians. First, we need to think, where actually is this? 5 over 3, that's close to 6 over 3, which is 2. So it's going to be 2 pi minus pi over 3. Okay, I'll sketch a reference triangle. And, seeing it's a 30, 60, 90 and labeling all the sides, once I get all that down, now I need to decide what's going to be positive and what's going to be negative. The hypotenuse is always going to be positive 1. It's the x and the y legs that can become positive, they can become negative. Okay, and I'm seeing down here in the fourth quadrant where x is positive and y is negative, so I should make the root 3 over 2 the negative number. Okay, cosecant of 5 pi over 3. Now, if we want to find cosecant, we should start with sine. Okay, so sine of 5 pi over 3, and think opposite over hypotenuse. Okay, so it's going to be negative root 3 over 2 divided by 1. Okay. And then to find cosecant, I will take the reciprocal. I'll flip the fraction. So cosecant of 5 pi over 3 is negative 2 over the square root of 3. And if we're actually presenting this as our answer, we're going to want to rationalize the denominator and say that's equal to negative 2 root 3 over 3. All right, now we're going to look at a figure with a isosceles right triangle. Legs of the triangle have length 16. That'll probably be important. Okay, segment CB is perpendicular to the x-axis. Okay, I think what this guarantees is that BOC is like split in half by OA. Pretty much we're looking at two 45, 45, 90 triangles that join up on the x-axis. Terminal ray of angle theta, which is not shown in standard position, goes through C. So I'm going to draw that real quick. Okay, that's theta in standard position. So that means it's going all the way right there. Even just theta right there. Okay, what is the value of 16 sine theta? Well, what we should probably do is just draw a reference triangle and use that to figure it out. It's like we've been doing all along. Okay. I'm just going to point out, because I'd like for you to know it, theta is almost all the way to 2 pi. It's short by 45 degrees. Okay, so that's pi over 4. Maybe I'll even say 2 pi minus pi over 4. 2 pi is 8. Pi over 4 minus 1 pi over 4, that will be 7 pi over 4. All right, 16 sine theta. Well, if we want to find sine theta, we don't need to use one with... we need to use one with hypotenuse 16. We can use our own. We can bring our own reference triangle. Okay, that's a really bad one, but that's all right. 1 root 2 over 2 and root 2 over 2. Okay, we know that that one's going to be negative. Okay, so sine of 7 pi over 4. Opposite over hypotenuse is negative root 2 over 2. I'm going to multiply that by 16, so 16 sine of 7 pi over 4. And I'll have 16 divided by 2 is 8. Okay, so negative 8 square root of 2. Because I told you about what happened in all the other quadrants, we'll have the same discussion about the fourth quadrant when theta is between 3 pi over 2 and 2 pi. And I'll just tell you that cosine and secant are both positive and the rest of them are negative. And now that I've told you all this, I'm going to show you this because it's a pre-cal class, but best we can tell, we don't think you're going to need this for AP pre-cal. Okay, this is an acronym. It's all my students take calculus, or at least college algebra. And so what we're saying is in the first quadrant, all of them are positive. In the second quadrant, sine and cosecant are positive. In the third, tangent and cotangent are positive. And in the fourth quadrant, cosine and secant are positive. And while there may be a couple of more examples in the notes book, I'm going to skip to the last one so we can get you out of here. And I'm going to work those other two on the unit review video. So the terminal ray of alpha in standard position intersect circle with radius 3.7, center at the origin. At this point, find these trig values. So I draw my standard trig diagram. Okay, if it's an intersect where x is negative and y is positive, okay, that's going to be in the second quadrant. I know the side lengths of the triangle I'm going to use to compute these sine, cosine, tangent values are going to be negative 3.5 and 1.2 because those are the coordinates of the point. And I know that the hypotenuse of the triangle is going to be 3.7 because that's the radius of the circle. Do a little SOHCAHTOA, simplify some fractions, and I've got myself an answer. Okay, so that's going to be all for this video. Thanks for watching.